Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 6, RK Bali navigation book. So far I have solved many questions. In this particular video lecture, I am going to answer question number 66, question number 67, 68, 69 and question number 70. So let's begin with question number 66. Aircraft is flying towards NDB on inbound track of 040 is asked to intercept and proceed onto outbound track of 330 by intercepting it at an angle of 40 degree. What should be the heading of your aircraft? So simple. Let's say this is your NDB station. Currently, you are tracking towards this NDB station on a track of 040. This will be track 220. Now, if you are tracking towards the NDB station, that means you are on this side of the NDB station and tracking a track of 040 inbound. But now ATC has given you an instruction to fly radial or to fly a track of 330 outbound. To fly a track of 330 outbound. Like this here. Okay. So now you have to change your course from going inbound like this to flying to turning left hand side, because that is where your track is. New track is like this. Intercept that track like this and then again turn left hand side and then start flying along this track 330 outbound. Correct? So this is what it should happen. So you are going to turn your aircraft left hand side. As you approach track 330, you are going to start making a left turn and then fly along this track. Now the interception heading is interception angle is given to you at 40 degree. That means this interception angle is 040. This interception angle is 40 degrees. So that means your current heading of aircraft I'm going to write it here, is 040, since it is flying a track of 040 inbound towards NDB. In order to intercept track 330 outbound, it will have to turn left hand side. The interception angle as given in the question is 40 degree. So the new heading of your aircraft will be outbound track 330 plus 40 degree. 330 plus 40 is 370 degree, but we do not have 370 degree. So subtract 360 here and you are left with 010. That means you will have to fly a track or a heading of 010. Okay, till you intercept this track and then turn left hand side, turn 40 degree again left and then fly along the track of 330. So correct option is option Bravo, 010. Simple. Next, question 67. Question 67. Turning error is maximum in your compass when? Now turning errors, very important. Turning errors happen at north and south headings. Okay. Next important point, acceleration, acceleration, deceleration, errors happen at east and west headings. Now let's focus our attention on turning errors. Okay, just remember this, east and west headings. Next very important point. Turning errors are dominant at higher latitudes which are close which are close to poles, which are close to poles. Okay. Next, another important point. If you are in the north hemisphere, let's say, and you are turning your aircraft along the northerly heading, your aircraft compass will be overactive. If you are in the northern hemisphere, the same condition. If you are in the north hemisphere and you are running your aircraft along south heading, compass will be sluggish. That means it will read slow, it will underread. It will be sluggish. Similarly, you can apply the same concept for the southern hemisphere. So correct answer here will be turning error is maximum when aircraft is turning through north or south directions at lower or latitudes, no. Aircraft is turning north or south at high latitudes, yes. Turning through east-west directions, no. East-west directions you have acceleration, deceleration errors, not turning errors. Aircraft A is on a certain latitude. It's not altitude, it is latitude. 60° north, flies at a speed of 230 knots, reaches back to the point from where it began. Aircraft B is on equator, does the same, assuming that the time taken by both aircraft is same. What is the speed of aircraft B? Simple question. So let's consider this is your Earth. First latitude given to us is 60° north. It is 60° north. The second latitude given to us is the equator, 0° north south, and we have 60 north. Now first aircraft number 1 is going to make a complete 360-degree rotation. Okay, is going to make a complete 360-degree rotation along this 60° north latitude and then come back to its starting point. That means it will cover a certain distance around the Earth, but the displacement is going to be 0. The speed is 230 knots. Speed of this aircraft is 230 knots. The distance that it travels is nothing but drumline distance, d long in minutes into cos of lat. D long, difference between the longitude is going to be 360 degree, a 360 degree rotation multiplied by 60 into cos of 60. So 360 into 60 into cos of 60 is 10,800 nautical miles. Now, you know distance, you know speed, so time will be distance divided by speed. 10,800 divided by speed of 230 knots, that is equal to 46 hours 57 minutes. 46 hours 57 minutes. Now in the same time, there is another aircraft which is making a complete 360-degree rotation along the equatorial latitude in the same journey time of 46 hours 57 minutes. And then coming back to its starting point, we have to find out the ground speed of this aircraft. Okay, so time is the same. Okay, so I'm going to write it here. Time 46:57. Distance, again Rumline distance, d long in minutes into cos of lat. So 360 into 60 into cos of 0. So Rumline distance equals to 360 into 60, 21,600 nautical miles. So speed of this aircraft will be, in order to cover 21,600 nautical miles, which is much more than 10,800 nautical miles in the same journey time, the speed should be much more than 230 knots. Speed is distance by time. So 21,600 divided by time of 46 hours 57 minutes is equal to 460 knots, is equal to 460 knots. So the correct answer here will be option Bravo. It's certainly, and you can also select this option directly actually without solving all this, and you can save your time. How? Now obviously you know that 60-degree north parallel of latitude covering a full 360-degree rotation along 60-degree north parallel of latitude will be will give a much lesser distance than covering the same 360-degree rotation along equatorial latitude. So distance along the equator, around the equator, will be much more than the distance around 60-degree north latitude because of the compression of the earth. So if distance is going to be more, so the speed required to cover that much distance in the same time is also going to be more. So you can definitely eliminate option alpha because speed cannot be the same as 230 knots. It cannot be less than 230, so you can also eliminate option Charlie directly, and you're left with option Bravo, which is 460. So even without solving the entire sum, you can just mark option Bravo, save your time, and go to the next question. But this is how you do it. Question 69. Airspeed entered in column 15 of your flight plan is always, so this is your flight plan, and there is, if you can see, this is your item number 15, and there is written cruise speed over here. So cruise speed that you enter is always the true airspeed. It can be entered in terms of kilometer per hour. In that case, you are going to use the letter K. You can also put the speed in terms of knots, and in that case, you are going to write letter N, November. So correct answer here is true airspeed. Next, last question. Rumblines on a polar stereographic projection are curves concave to the nearer pole, straight lines, curves convex to nearer pole. So remember all the properties of all the charts, mainly Mercator chart, Lambert's and polar. So if you know the properties of polar stereographic projection, you will be able to answer this question. Rumblines are curves concave to the pole of projection. So option A. So I'll stop here. I will do the next questions in the next video lecture. So do watch that video lecture. Practice all the questions that I have solved till now multiple times without looking. The more you practice, the more confident you become. Do watch other lectures that I have uploaded to my channel. Many nav lectures you will find, be it from radio nav, instruments, Oxford General Navigation, RK Bali, Keith Williams. So watch that video lectures. Resolve all your doubts, questions. You can let me know that in the comment box. And with this, I will request you all to share this particular video with all your friends who are preparing for the exam. hit the like button if you have liked this video lecture, and if you haven't subscribed to the channel yet, please do that. All the best.